Hello, and I am back with Vishnu to help you get ready for our upcoming OpenAI Hackathon. And today we're talking about Azure Machine Learning, which is very fundamental to AI. So thanks for joining us.
Wonderful. Thank you, Matt. Let me share my screen.
Okay. Oh, lost it. Got to share it again. There it is.
There you go. Let me bring up my slides here. Okay.
Okay, looks good.
Hello, everyone. Good morning, good afternoon, and good evening, depending on where you're located. I'm going to present about Azure Machine Learning today. And by the way, my name is Vishnu Pamula. My nickname is Lucky. I'm a cloud solution architect at Microsoft, focusing on the data and AI technologies. I'm also amazed by the quantum computing technology. So Azure has a Azure Quantum Service. So I'm a field ambassador for the technology. And I also love teaching and empowering others with my knowledge. So I teach as an adjunct professor, and also I have a course launched on Udacity. Machine learning is very near and dear to my heart. That is because I'm a statistician by training. I did my bachelor's and master's in statistics, and I've seen from past 2 decades, I've seen how the technology has grown from basic statistical modeling in the research lab into advanced modeling, AI, generative AI, and so on. It's pretty amazing how this technology has grown and helping businesses solve the problems. So I'm really happy to present this technology for you all. Before I do a deep dive on the machine learning topic, I wanted to give you an overview on the amazing AI portfolio that Microsoft has built for the customers. We have the tool sets for the developers and data scientists, where they want, if there is a need to build anything, from either from scratch, building the models, or use the customizable services that Microsoft has already made for you. Just use the service, customize them with your data, and get going. And also, we have applied AI services. So these services will work out of the box. You just spin up the service in Azure portal and start using them with your data. And also, Microsoft has done a pretty amazing job taking these technologies into the hands of the business users, into the Power Platform, and also into the applications like Office and even Windows and Bing and Xbox and so on. So machine learning is the heart of all these technologies, mother of all technologies that powered all these capabilities. Now, talking about getting the right insights from the business data so that the business users can take the right decisions. Azure has developed an intelligent data platform that has all the services that we need to get the right insights. For data stores like databases like storing your structured and unstructured data, analytical platforms like Synapse, and storage for storing your data and so on, your structured and unstructured data, data visualization using Power BI and so on, data governance platform like Power View and so on. So we have all the breathtaking technologies for the customers. And then to power the advanced analytics, machine learning sits on top of these services. When it comes to machine learning, we have 4 different capabilities that we need. Preparing the data for the models, building and training the models, deploying the models to production, And also, once we deploy the models, how do we make sure these models are healthy and giving the right results? So that is what this machine learning service provides, all those four capabilities, powered by the very supercompute power capabilities within Azure, and also for edge computes, like putting the models on the edge and IoT devices, security and compliance tools, very comprehensive MLOps capabilities for building the models, reproduce the results, automation of the models with the pipelines, deploying, retraining, and so on. All this is made seamlessly easy for the developers, where they can use the Azure Machine Learning Studio to build the models using the notebooks and using the AutoML, and also using the designer to drag drop the components and build the models. If we take a step back and understand the overall machine learning lifecycle, we have three different the phases. The prototyping phase, where the data scientist define a hypothesis. For example, a customer let's say is leaving, is not there's a customer churn, so the customer is leaving a company, not using the services. If we want to find out from the data why the customer is leaving, we need to define the problem and do the hypothesis and analyze the data and so on. So data scientists do that in the prototyping phase, where they take the data and define the hypothesis and build a sample model and test out the hypothesis. And then the model will be handed over to the developers. Could be data scientists, ML engineers, who can add more data, test various scenarios, and so on during the training phase. Once the model is trained and model is the developer is happy with the results, then the model will be sent to production, deployed to production. And once in production, we monitor the model for data drift and model drift, because the models are trained on the data. And then when the data changes over time, model may not know exactly how to make the predictions based on the new data. So that is where the model management and model operation comes into picture. On top of all these three phases, there is also underlying a managed layer, where we have tight security control, authorizations, and so on. Azure gives you those capabilities. So some of the features in machine learning studio. So there is automated machine learning. I know data scientists like to build the models from scratch using the notebooks, but for a citizen data scientist, a business analyst who does not have the skill set to build the models from scratch, they can use this automated machine learning model, where they can follow the wizard type of interface, selecting the model, selecting the data, and so on. Then AutoML will do the job for us. It will go through like a Kaggle computation between the models, give us the best model for that data. It can be used for various types of data, your tabular data, images, and also for NLP capabilities like classification and so on. The designer is also meant towards making it easy for the developers, data scientists, where you can just drag drop the different components in the model building process, like data preparation, model training, model evaluation, and so on. So this tool makes it very easy for building the pipelines. And for the developers, for the data scientists to build the models, Azure ML Studio comes with the integration with the Jupyter notebooks where you can integrate with GitHub repos and Azure DevOps, and even you can use Jupyter Labs, and also you can use VS Code from desktop, and also VS Code on the web. Another interesting feature is responsible AI. When we develop and deploy these models, and we want to make sure that these models are not creating harm for any users, harm in terms of excluding certain group of people from the models. Let's say you're deploying a credit decisioning model, and your model may exclude certain group of people based on their income levels and backgrounds and so on. How do we ingest those kind of capabilities into the model so that the business user can understand exactly why the model is making these predictions, how we can mitigate them, and so on. So Microsoft has done pretty amazing job over the years defining a framework for responsible AI and bringing those tools into the Azure Machine Learning, where you can just import the responsible AI library, Python library, and you can start uh, developing the dashboards, and so that you can see exactly what is happening with these models. Another interesting and important feature is MLOps with machine learning, or Azure Machine Learning. Historically, if you notice, the developers have been using the DevOps process for building the model, building the code, programs, deploying them, and so on. Machine learning can take the same process where data scientists and machine learning engineers can follow the same process, use the repositories like GitHub and Azure DevOps, train the models, validate the models, and so on. And also, when the model is in production, monitor the model and retrain them if there is any performance degradation. And when it comes to the infrastructure, depending on how big is our data, how variety is the data, we need pretty sophisticated and high power compute. Azure has got all those capabilities, all the compute needs. Purpose built AI infrastructure, highly reliable, and so on. And even giving the very seamless machine learning experience from anywhere from data preparation to model training to model deployment and to model monitoring and so on. And we've got built-in security, data governance, compliance, and responsible AI methodologies. Some recent announcements from Microsoft Build event in May. There, there are generative AI capabilities coming into the Azure Machine Learning. It's pretty amazing and interesting features. For example, model catalog capabilities, prompt engineering and capabilities. I'm sure all of you may have seen, based on the chat GPT and so on, you might have read about prompt engineering and how important it is to write the prompts and tune the prompts so that you can get the right output from the generative AI models. Responsible AI tools and Azure Content Safety Service, which can moderate the content, detect the harmful content in the data, and even fine tuning of these generative AI models. So all these capabilities are coming into Azure Machine Learning. Some additional details on the prompt flow. So this service helps you build the prompts and test the prompts, evaluate, and so on, and you can easily track these prompts and see how best picking the right prompting and so on. And also, you might have heard about fine tuning the large language models. In order for the models to give you the insights from, let's say, some domain specific data, could be some healthcare data that the large language models were not trained on, you can use the fine tuning to bring in your data. And Azure Machine Learning has that and is coming up with this capability for fine tuning the models, deploying them, and tracking them, and so on. With that background, I will go into the demo. If you are new to the Azure Machine Learning, you have to create that service in the Azure portal. When you log into the portal, you can search for Azure Machine Learning, and you will be taken to a screen like this. I mean, once you create the service, you'll be taken to a service like this, where you can see your resource name that you created and a few more details. What you have to do is just click on the Launch Studio, which will take you to Azure Machine Learning Studio, where you can do all the magic inside. So I have the studio already brought up here, so I'll go there. When you log into the studio first time, you will see exactly something like this: notebook samples, shortcuts, and so on. So in order for you to get started, we need to do some things upfront. As you might know, for the machine learning, we need the data. So click on the data tab right here, and we need to create a connection to the data stores. Data stores could be your Azure Blob Storage, databases, and so on. So we can click on create and give a name to it, select your sources. And once you do that, you will have access to all the tables and files in those data stores. You can see them in these links here. And the data assets are the individual assets like files, tables, and so on that you see in the data stores. So we need the data, so we need to make the connections. That's number one. And then we need to create a compute. In order for you to run the models, we need the compute. So here is where you can create the compute in the compute instance section, where you need to specify, click on new one, bring the size, whatever, how big you want to have the compute. Compute cluster is meant for training the models. You want to do the experiment with the models, and you need the large compute that scales up and down automatically. This is what is needed for that. And you can bring in even Kubernetes cluster. You can attach external computes like Synapse and Databricks compute and so on. So we need the data, and then we need the compute. Then once we have that, you can use these three interfaces here. Let's say you want to do the auto ML. So click on automated ML, new auto ML job. You can give a name to it. You can give a name to the experiment. Click on next. And we need to select what type of model you're building. Is it a classification model, regression model, and so on? Select the model and select the data set. Let's say I have a diabetes model that I want to predict if the person has diabetes or not. Click on next and select what you're predicting. In this case, I think Y has the the flag for diabetes or not. And you can configure the AutoML job how you want it to be. You can select the model that you want to run. If you don't select, what AutoML will do is it will run every algorithm that's out there, and it will give you the best algorithm for your data. So you can select run only random forest, run only a decision tree. So you can select which models you want to do. So you can follow the instructions and start the job. So for the purpose of demo, I'll show you the one that I ran recently. So once you run the job, you will see in the recent jobs, and it will show you the models that were that were added to the AutoML job, and accuracy of each model, how best the model is performing on the data. See, it ran through all of these models, and it picked the best model. So in this case, this model voting ensemble is the best one. So that is the AutoML job. Going into the designer, here is where you can use the simple drag drop features to create the models. You can just click on create, or you can pick some sample models that are out there already. But I'll just show you how to start from scratch. And you can pick the data sets from the data tab here. Like you see here, I have some data sets already. I can drag data set. And in the components section, you will see all the components that you need for the models. For example, I need this data might have some unwanted data, so I want to clean it up. So in the data transformation section, you can pick clean missing value activity. You make a connection, and you can click on it and specify what columns you want to clean and how you want to clean it, and so on. Right? You want to duplicate remove the duplicates. You want to add uh, value to impute the missing values and so on. You can do all that as part of these activities. So I'll show you one that I already used recently. For example, a classification model. You see how nicely it shows all the components that are needed for the model. So once you build the pipeline, just click on configure and submit. This will create a pipeline, run it, and the model will show up in the model section here. So for example, I did the same thing, and I have this model registered in here. From here, you can deploy this model as an endpoint. You can click this section and deploy it, or you can also automate using the SDK as well. So I already have the model deployed, so I'll go to the endpoint and show you the endpoint and REST API URI that you can use in the applications. So like here, just copy this and start using from your applications. Then the notebooks category area where you can build the models without using AutoML or Designer. I know data scientists prefer to use the notebooks from scratch, so I want to show you this as well. So I have some sample repo that I got from GitHub, and this is the GitHub repo. You can search for Azure MLOps v2. This is the repo that I'm using. This has got pretty detailed and sophisticated end-to-end lab, so you can clone this repo and start using it. So as you see here, let me make it a little bigger. So what I'm doing here is I got this notebook, and I'm using this compute to run the notebook, and it's using Python environment. And that's it. You can start using the notebook here. So this is a sample code, how to authenticate to Azure, how to connect to your subscription and so on, and code to get the data and so on. So there is a very detailed instructions on this. So you can follow this and execute the cells one by one, customize for your needs, and you can take it all the way through the end, and the model will be created, model will be deployed, and so on. So basically, I use this notebook to get the model till the endpoint. And I also want to show you the responsible AI as well. So here is the responsible AI repo. Again, you can clone this to the environment, and you can build the responsible AI dashboards for the models, any model that you're building. And it's got very nice detailed dashboards. I'll show you one sample on how it looks. So there is a sample dashboard, a tour of the responsible AI dashboard. So if you scroll down, it will show you various error analysis where the model was able to predict well, not predict well. It will give you exactly those details, and you can drill down, exactly where the model has not done well, so you can pinpoint exactly which block of data that's not being predicted well. So I would highly encourage you to try this repo, the end-to-end repo, as well as responsible AI. And finally, I want to show you how to integrate with the with the DevOps tools like Azure DevOps, so you can do the MLOps at scale. So if you go to the Azure DevOps, again, you can follow the instructions on this page here, like MLOps with Azure Machine Learning. And once you follow the instructions to build the pipelines, here is how you will see how you basically deploy the models from your dev to test to prod, and so on. It's pretty seamless. These tools work very seamlessly to deploy the models and monitor them and so on. So what this pipeline is doing is exactly automating everything that I did in the notebook here. All that. So I got the data, I created the compute, I built the notebook, which can prepare the data, train the model, deploy the model, and all of that is automated with a single button. Just click on the button, it will take care of it. So I would also encourage you all to go through the MLOps lab as well. So that's all I wanted to show. I hope you liked the video. All the best.
Thank you so much. You covered a lot very efficiently, and look forward to seeing everyone at the hackathon. Take care.
Wonderful. Thank you, Matt. Thanks, everyone. Take care.